Number 2 is another example of where using those identities is going to be helpful. So you could absolutely change everything to sines and cosines on number 1, or you can change tan squared plus 1 to secant squared. And I think I might show you both on this one. So 2 paths. The first path would be to use, go ahead and swap in tan squared plus 1 is secant squared. If you didn't see that Pythagorean identity to use, then what I would do instead is change everything to sines and cosines. So I'll show you that first step over here. So tangent squared is sine squared over cosine squared. You have the 1 in the middle. Tangent is sine over cosine. And secant is 1 over cosine. So go ahead and pick which way you like. Sorry, there was an announcement. Go ahead and pick the one that you like the one that you saw. Seeing that first step is the most challenging part of Trig. So pick the first step that you like and try to get a couple steps ahead of me. I think I'll work one and then from these one and then the other. I'll do both methods for you. Okay, hopefully you paused and got a couple steps ahead. I'm going to go ahead and work this one that's the secant squared here for a couple and get it done. And then I'll go over to the one with all the sines and cosines. So at this point, I would, on my secant squared plus tan secant, change everything to sines and cosines. So secant squared is 1 over cosine squared. Tangent squared is sine over cosine. And secant, remember these are two terms, it's one term, but they're multiplied together. Secant is 1 over cosine. And then, my first term isn't going to change here, but I can multiply across. Sine times 1 is sine. Cosine times cosine is cosine squared. Always keeping an eye on my goal here. I have a common denominator built in. I can just combine these two terms over that common denominator. Using that first Pythagorean identity, changing tangent squared plus 1 into secant squared builds in the common denominator for you. And that's what doesn't happen in this other method. So if from the beginning you were thinking, hey, on the right side of my equation, I have all sines and cosines, so I just want to change everything, that's lovely, and it's a great method. The thing that you have to recognize is this 1 in the middle needs a common denominator. Your first term here, sine squared over cosine squared, is lovely and ready to go. Your third term out here, sine plus 1 over cosine times cosine, we can multiply across. Sine times 1 is sine. Sorry, I think I said plus. It is multiplication in the numerator. Cosine times cosine is cosine squared. But we need to change this 1 and make a common denominator. So our common denominator here is cosine squared, so I need to multiply the top and the bottom of that fraction. Change my 1 into cosine squared over cosine squared. So once you have that common denominator created, you can write your whole numerator over your denominator. And then you just have to remember that sine squared plus cosine squared is 1. So one proof, 2 ways. There's a lot of overlap, but obviously I think using this Pythagorean identity keeps your life a little simpler. I think that is really helpful. There's enough going on with these. These look complicated enough without introducing more places where you could make errors. So look for those Pythagorean identities. Be careful with your algebra.